Okay, similar to the an earlier one we did with the rectangles, this one is with triangles, but it's also talking about the relating the perimeter to the number of triangles. So, okay, which of the following represents the above situation? Um, First thing I'm going to do, because this is just really handy for me to organize my mind, is I'm going to make a table. Okay, I'm going to say triangles. This is the number of triangles, and this is the perimeter. Okay, so the number of triangles. We've got one triangle has a perimeter of 17, and I just counted that up over here. Okay, two triangles has a perimeter of, uh, well, we had two sixes and a five. Well, here we have two sixes and two fives, so that adds another five on there. So that's 22. Okay, here it's a couple of sixes and three fives, and what it appears to be happening here is that every time you add a triangle, you increase the perimeter by 5, because what you're doing is you're getting either another thing here or another thing here. But the sixes, one on each side, happens uh, every time. So we've got kind of like a plus 12 from these, and then however many fives we've got corresponds to the number of triangles. So the perimeter is equal to the length of a side of one triangle multiplied by the number of triangles, plus 2 times the length of the base. This, no, I don't like it. Again, as I just talked about it, and I'm going to write this in case you didn't have multiple choices and you had to just come up with it, we're saying the perimeter is equal to, first of all, we can see that there's an increase of 5 here every time, plus 5, every time this goes up by 1. Okay, and that means that we're going to have a coefficient of 5 on the variable. Okay, the number of triangles, t, times 5, because we always know that an increase of 1 here leading to an increase of 5 here must be a coefficient here of, let me move that down, I think I ran into that, a coefficient of 5, taking that plus 1 and turning it into an increase of plus 5. Okay, now let's see just what would happen. Remember, we also have this. We have a 6 on this side and a 6 on that side every time. 6 on this side, 6 on that side, for a total of an extra 12. So we've got 5t plus that extra 12. Okay, which makes sense, because if we were to then go up here and say, I'm going to erase these marks for a second. Okay, but up here, if we said, well, if I put in, let's say, 1 right here for the number of triangles, okay, 5 times 1 would only give us 5 if we were multiplying the number of triangles by 5. 5 times 1 equals 5. How do we get from 5 to 17? Plus 12, right? If we had 2 here, and the coefficient here was 5, 2 times 5 is 10. How do we get from 10 to 22? Plus 12. We always need that plus 12, and that corresponds to this 6 and that other 6. This 6 and that 6. This 6 and that 6 on each, one on each side. Okay, so essentially we've just got the equation P equals 5t plus 12, which I see down here, and let's read the description of it. The perimeter, P, is equal to the length of the base of one triangle, that's this 5, okay, multiplied by the number of triangles in the figure, right? That 5, the length of the base times 5 times the number of triangles, because you're seeing the base there, and we're seeing the base of each triangle, seeing the base of each triangle, okay? Plus 2 times the length of another side, okay? 2 times the length of another side. We got the length of the other side twice, and then that's the equation. It may be easier in these types of problems to just write it yourself, make a little table and write the equation yourself without having to read through all this. And then if your answer's there, great, okay? Because it can get a little wordy and confusing, and it might throw you off more. Let's do the next slide and see. Okay, this is, we had just made the table actually, so this is fine for number 12. In fact, I'm going to fill it in because I always like to refer to the table. Number of triangles, 1. Perimeter, 17. Number of triangles, 2. Perimeter, 22. Remember, it's increasing by 5 every time because of the extra 5 base that you've got. Okay, 3, 27. So I like to have that there as information even if they didn't ask for it. Okay, so suppose you know the perimeter of n triangles. Number 11. N triangles. How do you find the perimeter of n plus 1 triangles? Okay, so you're adding one more triangle on. What does one more triangle added on do? It adds a total of 5 extra on, right? Okay, every time you add another triangle, we get 5 more added on. So suppose you know the perimeter of n triangles. If we added one more triangle, what would be the perimeter? It would be 5 more. So you just add 5 to the perimeter of n triangles, and now you've got n plus 1, or one more triangle. Every triangle adds 5. Yep, so that's the answer for number 11. Again, the table we've just filled out, we already had, and we've got one more slide, and let's see how we do for the rest of the problems related to this set of triangles. Okay. Represent the relationship between the number of triangles and the perimeter. How does this equation relate to the method you'd use to find the perimeter of n plus 1 if you knew the perimeter of n? Well, remember, we're increasing by 5 every time. Every time you add another triangle on, we increase by 5. So the first one, if we go back, if you look back at the table, one triangle is 17. So we say, I'm going to go over here to 1, and I'm going to go up here to 17 and say one triangle has a perimeter of 17. Two triangles is 5 more than that, 22. Three triangles is 5 more than that, 27. Four triangles is going to be 5 more than that. Five triangles, 5 more than that. Oops, 5 more than that. Six triangles, 5 more than that. And that's a linear function. It doesn't make sense to say back here, right here, 5 less than that, because that would be 0 triangles, which would have no perimeter at all. So that's not a logical thing to put. Okay, but that's how it looks, increasing by 5 every time. And that's what they're getting at here with how does the equation relate to the method you use to find the perimeter of n plus 1 if you knew the perimeter of n triangles. One more triangle would add 5 more on, and that's why every time you go up by 1, the y amount increases by 5.